And now we are able to understand the map reading process also because just we have completed with various aspects of storage level. Because as always, we insisted on Hadoop is a combination of storage and as well as the processing layer. Now, let me introduce which are all the objectives we are going to talk today. So initially, okay, some of the inputs I'll be giving to you related to the MapReduce, what exactly MapReduce and all, and extensive discussion on job tracker and task tracker information. And thereafter, we'll take some example of MapReduce, and then we'll see how we are going to submit the job. Okay, job submission to the cluster. Okay, so far we have submitted some commands. Of course, those commands are related to Hadoop distributed file system. But the other part, once you are familiar with Hadoop distributed file system, then you can make use of okay other functionalities also related to your MapReduce. Okay, so the current session objective involves the usage of MapReduce and how it is helping the developers so as to perform some kind of activities. Reason is pretty simple, friends. In case of the Hadoop distributed file system, and everything we can perform is to create a directory or to store the data or to import or export the data. These kind of actions we have seen. But beyond that, if I'm having some task to perform or if I'm having some application and as a result of that particular application programmatically, I want to get some kind of outcome. So in that particular case, just I can make use of this MapReduce functionality. Okay, but before going to launch what exactly MapReduce is, to lighter the understanding, okay, just let me share the few commands left over because earlier we have seen some of the commands. Now again, we are having some other command sets. So just we can make use of these particular commands further. So just these are all extension of the earlier work. So just whatever we have seen in the earlier thing, like specification of our replication factor and creation of some directory, and thereafter we have seen some creation of the files importing into directory. All these aspects we have seen. So as a continuation, 5 or 6 commands I am introducing to you because MapReduce is a heavy 2 hour topic, guys. So there is no, there is no kind of a deviation must occur. That's what I am initially completing these aspects. Um, and once that is over, then we'll go through the MapReduce aspect once these commands are over. Okay. So let me introduce this thing. Let me log into our cluster. Okay. So now just I'm having this ls and as well as Hadoop fs-ls. These two are most commonly used commands where you can uh, get the information related to the local file system and all and Hadoop distributed file system. Uh, just we have seen some other commands also HDFS, DFS like that. Maybe if I am working with some memory oriented kind of aspects, I can perform those functionalities also. Now, rather than copying or importing or exporting the data from LFS, sometimes there is a possibility of getting the data from HDFS into HDFS. Then in that particular case, there is a typical copy command is there, guys. Like so just you can make use of this thing Hadoop FS -cp typical Linux-based kind of thing. I'm having some stock data with me. Okay, so this particular stock data also available in HDFS only. That's what I'm listing out all the files and directories. And this particular stock data, I want to store. Earlier, we have created some folder data science DS in the name of. Just what I'm doing is just I'm making use of this stock 2. Okay, already stock 1 is there in the Hadoop distributed file system. But I don't want to disturb the original file. Maybe the admin, Hadoop admin decided to give that file to separate in a separate folder to the users. So in that particular case, just you need to identify the file from the Hadoop distributed file system just to maintain that as a source. Actually, our habit is we'll make use of that copy from local or put command, and we'll be taking that whatever the functionality I'm having from the local file system, whatever the name of the file I'm having, just I'm placing that into the HDFS. That is our general convention. But whereas friends, in case of the scenarios, maybe I want to make use of the file which is available in the distributed file system, and I want to copy the same file to other location. The situation arises sometimes. So in that particular case, you can make use of the CP, which is a way of copying the HDFS file into another location provided by the user. Okay, so just if you are observing this thing. Okay, now how to verify that? Just you can go through fs-ls specifically. If I'm giving direct ls, it will give all the information which is available in the user. Okay, so but whereas if you are talking about the specific folder, I can make use of that particular folder and we can venture all the availabilities. So just now, if you see, we have copied this stock 2, okay, from stock 1 file, which is available in HDFS, and in the same way we are performing the activities. Now, sometimes you may ask me, like, why do we maintain multiple copies? The first thing is, friends, maybe if I want to maintain replication and if I feel that particular file is a important one for me, then in that particular case, I have to maintain the multiple copies. But at times, if memory is also precious to me, as I am dependent on some AWS or GCP kind of thing, in that case, I have to move the file. Okay, file moving is also one of the possibility where I can make use of the convention. Now you observe here how I can move the file. So just I am typing this Hadoop FS hyphen MV. Okay, just I am moving that particular file and I should give the file information from the Hadoop only. Okay, just if you refer this file moving, and what I'm doing here is HDFS3, and that is the file which is directly available. And this time I want to move this file to my data engineering location. Assume that two projects are running parallelly in India. So one is data science project, another is the data engineering project, and maybe data engineering guys load the data and they pre-process the data, and then they will downstream the appropriate data to the data scientist team or machine learning engineers. So in that particular case, this data engineering guys should have some source data where they pre-process and they handle all the um, whatever the data they are having, they want to maintain the appropriate information up to the level of usage. Okay, maybe the data is in all shapes. The data might be having some null values or missing values or many pitfalls would be there. So as a data engineer, just the data engineer should pre-process the data so as to hand over the data in a nicely formatted way. So in that particular case, just we can make use of another source file. So that is the scenario. So in that case, just what you can do is whatever the file I'm having, I don't want to keep these particular files at multiple locations. So just I can give this Hadoop fs-move hdfs3 de and I can give this as hdfs source. Okay, because this is the file where I want to apply all the pre-processing techniques and all, and I'm making that name as HDFS source file. Okay, just to enter this. Oh, sorry. So multiple times I have given. So just you can see here Hadoop fs-mv. Now you see, guys. Okay. So initially I have to check whether my local this HDFS is containing HDFS3. It should not be. Now earlier we are having HDFS3 here, but after moving this file from HDFS to data engineering folder, so just we are not having that file. But I need to clarify whether it is available in DB. So how to do that? Hadoop fs -ls de slash. So obviously you will be getting that HDFS SRC. So whatever the file I'm having. And similarly, if I want to display the content, okay, so just the common thing, I need to mention the folder along with that the appropriate file information also. Okay, so whatever the information. So here you can copy the file from HDFS to another HDFS folder, and you can move the file from HDFS to another HDFS folder. Those things you can observe. And moreover, especially as we are seeing, if you want to perform some kind of activities exclusively on this DS or DE kind of the folders, specifically you can mention this kind of the convention. And one more option we frequently use this as a big data developers. Just we need to observe this recursively if I want to list out the files. Okay, so recursively, if I want to perform some kind of activity, just you see here, what is the difference between normal LS and this one? In case of the normal LS, let me type the command also. So Hadoop FS, if I'm giving -ls, just it is showing the appropriate access mechanism and as well as who is the user and how many bytes are there occupied by, and we're having this replication factor as a second column. But in case of LSR, which is recursively, it is giving the knowledge. Uh, if you observe this particular LS, only it is giving the directory information. Okay, just to see directory information, and it is not revealing the inside data. And even MR1, MR2, MR3, these are also directories, which is not giving any knowledge on that. Okay, which is not giving us, which is not revealing any internal files which are there in the these five folders actually. But whereas if you want to see the actual files or actual inside data, okay, directly from this particular command, then you can make use of this Hadoop fs-lsr, which is recursively. So in a way, what it does is, friends, just it is providing all the how many number of files are there, those many times this row will be displayed, and this diggy, okay, is a folder. Of course, it is giving that information to us, and then the diggy is having some stock market data, HDFS 100, HDFS 2, HDFS source, like that. Internal files are also there. So recursively, it is going to traverse the appropriate information. And similarly, it is narrating us your DS is a folder, and within that particular folder, we are having sales.csv, stock data, stock 2, like that. And apart from that, we are having some other data sets related to that. And similar to these kind of the conventions, MR1 and MR2, I'll explain, guys, what is this part and success because this is a typical outcome of the MapReduce job submission. So just to observe that as of now, this MR1 or MR2, MR3, all these are nothing but the folders. Inside that folder, we are having the files. As how we have seen in DE and DS, how we are getting the file information. In the similar way, these folders also having the files, okay, sub files and all these things. Okay. So this is how you can make use of the functionality while making use of the convention. okay, in the Hadoop distributed file system. I'll note down everything in the OneNote. And one more thing, maybe if you observe, we have used that VI and LFS1 for the sake of creating a new file. Just it is taking us to the existing thing. And what I can do is just I can make use of I. So just now it is in the insert mode. Okay, so this is a new data. Okay, which is LFS info and can be imported to HDFS. So just this GI is one of the editor, gedit, where many editors are there. So VI is one such kind of editor. So whether you can create, if you want to create a new file, that you can make use of the VI space file name. And the file is not there, newly creating Hadoop, this local file system creates new file, and then you can feed the data. Suppose
Pablo,
if
sorry to interrupt you. Your
yeah,
voice is breaking.
is it 1 minute? Let me put another. It is breaking, guys. For all, please confirm, friends. The problem persists with all, or
Yeah, now it's clear.
Now
it's
it's
clear.
clear, sir.
It's fine now, sir.
Oh, okay, no, thank you, thank you. No, I have used only one Bluetooth device. That's what I keep both the things now. Now it is okay, na? But whether it is breaking or in a feeble or something like that.
Now it
It
is
was
okay.
breaking before. Now it's fine.
Oh, maybe okay. Yeah, yeah. Okay, okay. No, thank you, thank you. Sorry for that. Okay. So hope you got the idea, na? Else shall I repeat once again? Is that fine, na? Command orientation. Okay.
Repeat once.
Repeat. Okay, definitely, no problem. Yeah. So let us start with this thing. In that case, let me uh, go back and see. Yeah. So no problem. Yes. So initially, we started our discussion to copy the file from HDFS to HDFS because, friends, our general habit is generally we import the file from LFS to HDFS and we export the file from HDFS to LFS, like that we have seen. But whereas at certain point of time, so there may be a possibility of transmitting the files from HDFS to other location of the HDFS. Further, sir, let me show you which are all the files available in the Hadoop FS-ls. This probably shows the orientation of which are all the files and directories available in the Hadoop FS-ls. Now, what I am doing here is just I want to make use of a corresponding storage. So whatever the sales or whatever the stock I'm having, and from this particular HDFS user to a specific directory. So for that, I'm having this thing, guys, Hadoop FS, just a CP command, which is nothing but a typical copy, and you can make use of sales one. Now I want to copy this sales one data to DE, guys, and sales one SRC. So what it does is within the HDFS, whatever the sales one file I'm having, so that particular file will be selected and it is going to place with the specified folder provided by the user. So now if you observe this thing, so just we have copied a sales one file to the DE folder. Again, if you observe Hadoop FS-ls, just you can make use of our DE folder. I want to see the DE folder. Just it is going to display. Just now we have stored the sales one underscore SRC. Okay, and along with that, which are all the files available. So if I want to specifically observe those kind of the things, just you can make use of this Hadoop FS-ls and directory information. Similarly, there is a possibility of moving the file also. Okay, so file moving generally gives that only one location I want to preserve. At times, friends, what you can do is now, while making use of this copy command, sometimes already replicated file is already replicated in Hadoop. Again, if you observe, you see here sales one is replicated twice here. If you see sales one is replicated thrice, and in DE folder also our sales one SRC is replicated thrice. provided the same file we are giving six replication logically. Logically, in the user, it is having three times. It is allowed three replications. Again, in the folder, uh, there also Hadoop is maintaining three replications. So to avoid these duplication, so just you can make use of the move command. And it all depends on the scenario. That's what I'm saying. Sometimes the project team or the project originators may decide that we don't want to miss out the source data at any cost. So in that particular case, obviously, definitely they have to keep multiple files, okay, as the interest of the importance of the data items. So of course, however, the memory is very cheap. That's what Hadoop is insisting on commodity computing, commodity hardware, which is a cheap hardware where I can attach some hundreds of the machines to my Hadoop framework into the cluster. So in a way, it is helping us to perform the activities of storing and as well as the processing of the data. That is one side of managing your source data in a valuable format. But some cases, then there are certain situations where we don't want to again replicate the appropriate information, and our perspective is free replication, which is provided by Hadoop, is perfectly all right. And moreover, if I want to change that particular replication from 3 to 5, however, we're having that command. Set rep command is there. Yesterday we have seen. So with the help of that set replication, what you can do is you can perform the activity of okay raising the appropriate replication into multiple times. That is always there. So if you want to perform these kind of sources, and I don't want to repeat the appropriate information multiple times, what I can do is I can make use of the move command. So what I'm doing here is abc.csv. Some file is there with me, and that file I want to store into some other location. So this time what I'm doing here is some src abc. Like that I want to move the file. Now if you observe, obviously if I want to see a plain ls command, so just obviously I should not get the abc. Earlier if you see abc.csv is there, but now after moving your file from HDFS to this data science folder, only once we can see. But let us confirm that also. So just if you are making use of this LS and data science. Now if you see this source ABC file is there. Source ABC file is there. And we were talking about the displaying of the file also. So how to display that file, guys? So first let us clear. And now if I want to see only specific folder information, I can make use of this convention, Hadoop fs-ls, and as well as you need to give the corresponding folder data. And if I want to pick up, okay, hyphen cat, so ds slash. Now what I want to do is I want to fetch the src abc file. Okay, like this. Maybe, and I already have mentioned things. Maybe the good idea to view the file content is it is most in an unformatted way or something like that. If you feel that if I want to get the file in a more formatted way, just the option is go to the Hue login portal and just you type your username, uh, whatever the username I'm having. So just I can type this, and then within this, just to apply the refresh. Maybe sometimes whatever the activities we are doing, it takes some time. So in the data science folder, again I'm having src abc, okay, which you can see in a nice format without any weight. Okay. So likewise, this file browser helps you to get the information. Of course, nothing wrong in going through the command prompt and all, but there are other options I'm saying. So in a view and visibility wise, if you want to perform some kind of activity, then you can go to the view login portal. Let us clear this. And once this is over, friends, and there is one more command we were talking about, that is the LSR actually. So LSR, what it does is just it is now if I'm making use of this thing, it is hardly giving the listing of files, and we are not having any information about the directory. So if you see this, we are having DE and DS as directories, MR1, MR2, MR3 are the other directories. And it is one more thing, it is showing us occupancy as 0. Okay, so as to identify how many files are there inside that particular folder, just I'm having the Hadoop FS-LSR. Okay, recursively, if I want to view the appropriate content in the folders also, then I can go this, I can make use of this DE, and obviously, which are all the files I'm having, Apple stock, HDFS, all these kind of the conventions you can observe. Okay, this is very useful construct friends because within the folders, generally, if you are using only ls command, it is not going to give us any internal details. So as to maintain that particular convention, definitely I should use this LSR command. One more functionality I want to give to you is the people who are pretty familiar with Linux, they can make use of the gedit or veditor so as to handle the things. Now, suppose if you want to create a new file, so generally VI, what I can do is whatever the name I want, okay, a meaningful name should be given because the same file will be used by multiple members. And one more thing, guys, as a good programming practice, no matter whether that is SQL, Python, or Java, or even MapReduce also, always preferable to give the meaningful names to the variables and as well as functions and programs. Okay, in a similar way, just I am giving this VI editor, VI space file name, and it leads to some more editor friends actually. This editor gives that the space for feeding the appropriate information. Now, what you can do is just to give the escape and as well as insert. Now, it allows you to enter the data. So, this data helps us to work with just LFS and HDFS. Okay. Once this data entry is over, if you want to work with some kind of the local file system import or export, once this is over, then you can go with the escape and shift colon WQ. Okay. So now it is coming back, and if I want to see the files available in the local file system, just you can give the ls command. Now have a look on this LFS1, just to have seen that LFS1. So however, to display that particular content, you need not go always VI and use that escape and shift colon WQ, not required friends. Just you can make use of this cat and you can use this LFS1. So obviously, you can display the contents of that particular file. Now, one more point I want to emphasize that so how we are making use of how much we need for the sake of Spark or Hive or Hadoop distributed file system. Only we are going through those commands only, friends, because Linux itself is having plenty of commands. Okay, but the scope of our discussion is just how we are making use of the import and export and how we are performing some copying and moving of the files and thereafter, if you observe the job submission, both in case of the Hadoop and as well as the Spark, and while using the Hive, Pig Latin, Scoop. Whenever there is a reference, whenever there is a requirement, up to that only we are focusing on these Linux commands, right? Okay. So don't feel that and some other Linux commands we need to know. No, no, friends, not required. So whichever the reference and whichever the commands are required for our learning, definitely I'll scope those particular things, right? Okay. Now, one more thing, guys, here in the earlier examples, because today also we are going to use that WinSCP. Okay, today also we are going to use that WinSCP. That WinSCP, if you observe, it is something like is a utility program where you can copy your local machine files into the cluster local file system. So at times, I'm having some resources in my machine and I want to make use of the resources into my Hadoop file system. Maybe the input files or maybe some of the developers they have designed some programs for us. And as a Hadoop a developer, we need to submit those particular programs to the corresponding cluster. See, friends, here the advantage is the Python developer need not always know about the Hadoop. And similarly, Hadoop developers need not know need not be expertise in Python. But Python developer, of course, after implementation of some kind of the Python files, he or she supplies the corresponding Python files to us. So in that case, it is our responsibility how we are going to make use of those files and how we are going to submit the jobs to the cluster is most important thing. Okay. Today, however, I'll show you after getting your Python file from the developer, how we are going to make use of those particular files and how we are submitting the jobs in the context of the Python. And in that particular process, we can understand the MapReduce scenarios also. Okay. So that is the Venice CP. And another thing is we have seen the GUI based kind of this inference. Like directly I can upload some of the files into Hadoop distributed file system. But I strongly discourage this direct path kind because uh, especially this is a security kind of thing. And moreover, Hadoop admin may not allow us to directly access this GUI kind of thing. Because this GUI view portal is something like which directly I can go and delete some of the files and I can play around all these aspects. Okay, we are having some freehand here. So, but in the heavy projects and that too, we are running terabytes of the data, petabytes of the data. In that case, guys, it is very tough to recover the data if you remove. Okay, so generally, but knowing is important. That's what I'm saying this particular fact. So graphical user interface Q login portal is for the sake of displaying the data that only. But left and right, if you are copying and if you are moving or deleting the files, which may cause some trouble to the team. Okay, just be cautious while accessing this particular view login portal in future also. Okay. So with this, just we can make use of our OneNote. So let me notify which are all the aspects we have done as a part of this thing. Uh, the new members, okay, just I'm insisting you guys go through the earlier videos because heavy dependencies it's not like individual or independent topics, friends, especially Praveen and who is that Akrama. So Wasim Akram.
Yeah,
Yeah,
sure,
sure.
sir.
Yeah.
Sure.
Yeah, so
Very good.
welcome, friends. So just you need to work hard compared with other guys, right?
Yeah, sure, Pawan.
So I'll be with you, no problem. If any at any point of time if you are facing any difficulty, just to contact me, guys. Okay, definitely. And moreover, I'll be pasting the Slack channel also once again. So because all the materials and all the kind of inputs I'll be posting in the Slack mode, so you can download and you can make use of the practice of these things. Okay, right. No problem.
Okay, Pawan. Yeah.
Sure,
Yeah,
sure.
all of it, then do well, huh? Right.
Thanks, Pawan.
Okay. Yeah. Okay. So, and now just let us have a look on this, how we are making use of these conventions of so far the commands. The very first command is just where you want to copy HDFS file to uh, other HDFS location. Okay. So just a simple command. Just I am making use of this Hadoop FS hyphen CP. Uh, Sales data is the resume that sales one. And for the DE team, I want to give this DE sales underscore SRC. Like that I can give. Now to verify the content in DE folder. Okay, so just you can make use of this thing. Hadoop fs hyphen ls DE slash. Then obviously you will be getting all the kind of the files information along with your sales underscore SRC. Now, third thing is to view the content. Okay, to view the content in the folder or directory. In this particular case, guys, just making use of just the same command, hadoop fs -cat, but explicitly we should give the folder and as well as our a newly created or newly copied content. Then obviously it is going to allow us to view the content. Next example, we have seen to move the HDFS source file to other HDFS location. Okay, other HDFS location. Simple. So just I can make use of Hadoop fs -move. Whatever the file I'm talking about, maybe HDFS3, and this time I am using the data science project team and SRC HDFS, like that I'm taking. So then, if I'm going through and see this LS, okay, there should be no HDFS3. Okay, this just you observe this point. And coming to the other things, maybe to see the directory recursively. So if I want to view the contents of the directory recursively, just I can make use of Hadoop fs -lsr list recursively. Okay, generally LS only gives the plain information, but LSR just it is giving the information recursively. And seventh one, in local file system to create a file. In our cluster friends only we are having the support of vEditor. Otherwise, you can use gedit also. Gedit is more flexible, like how your notepad or however WordPad is helping us, just to feed the data. Similarly, gedit is there, but here we are having VI just to give the file name, maybe LFS1. Then it opens one editor for you guys. Once you enter this particular data, it opens one editor. And very first point is you have to press the escape and press the key I. Then it opens the insert mode. So you can see here the insert option. Then you can feed the data. So here you can enter the data. Okay. And once the data entry is over, what you need to do is this is the first step, of course. Yes, escape and insert and feed the data. Now, once the data entry is over, just you need to press escape plus shift colon. This is the command. It's okay. So because this escape is coming out from the insert mode and shift colon along with writing and as well as the quitting. So that means it is automatically save the file into whatever the content we have given. It is going to store in LFS1. Now, how to view that? So, what is the command number 7? Okay. How to view that? To view the content. So, just what I can do? Just you can make use of cat LFS. That's all. Okay. These things, however, some of the commands already we have seen, and some like copy and move, LSR, all these things you can practice. And however, I'll be sharing the installation procedure. So let me open that installation procedure, friends. Because this installation procedure is bit tricky because as I'm directly using the appropriate the command already which is established, so directly I'm using. But whereas a few members asked me how to install in our machines. So for that, just I'm walking through the steps, friends, actually. So these are all nothing but with the help of your virtual machine. However, I will be posting this document in the Slack mode. So you can go through and you can make use of the appropriate steps and install Hadoop in your machine successfully. You can install. So of course, as I said, friends, Hadoop is completely working on top of the Java. Okay. So first I have to install Java. And for this particular thing, just to need to already we are assuming that some virtual machine we are having, and on top of this particular virtual machine, okay, you are going to install Java. So how do we do that? Just you need to mention the host name, username, and password of that Linux machine. Okay, already we are having some virtual machine after installation. Just you need to start installing the Java on the Linux. Okay. Now this Java installation, just I have clearly mentioned system IP and whatever the username and password. After logging in, generally the WinSCP procedure I have given here. Just copy the corresponding commands and you can make use of that thing. And in case of the Linux friends, it is very straightforward to install the softwares. So once you see the JDK software in the Linux machine, CH mode is nothing but change mode command. Change mode is something like uh, as Linux is a multi-user operating system. Here the permissions playing a vital role. Okay, permissions playing a vital role. So definitely you should make use of this particular permissions. This 777 gives the reading, writing, and execution permission. Okay, so together it forms seven. So for all the users, okay, local user, remote user, external user, like that, different categories of the users are there. Just to remember that if you are giving three sevens for all users, reading, writing, and execute permissions were there. That is the understanding. So whatever the JDK software I have copied from Windows to Linux machine, I should give the permissions. Okay, and once that is over, just dot slash JDK, first three letters after giving, if you press the tab, it will fill all the aspects. So then automatically Linux takes care about the installation. Now you check the Java version, and if you want to work with Hadoop 1, 2, or something, minimum starting from sixth JDK version only. That's what I clearly mentioned. 6, 7, 8, anything is okay. So once the Java installation is over, so just you can check the installation in user Java JDK. Okay. Now in the Linux itself, just you need to create the user friends. Okay, user add. Just you can give the username and password corresponding to that password of the username. Again, you need to enter the password. Okay, this is not password is not the username friends. Password for the username. Again, you have to enter the password here. So that means user add. Suppose I am giving Praveen here. User add Praveen and password for Praveen maybe XYZ. Like that, we can give and give you username and password any names. After completing this step, log out from the root user. Again, log in within your new user because just now you have created the user. Observe here, guys, your JDK installation must be in the root folder. If you are familiar with the Linux operating system, root is the user. If you install something on the root user, which is going to reflect on all the users. So that means suppose if you are installing Java in the root user, maybe after that, if you create n number of users, generally that is a practice, friends. Even in our cluster management or virtual machine management also. Suppose if I am creating or if I am installing my Java in a specific user, then obviously the reflection is with respect to that user only. Okay, but whereas if I want to maintain the convention of whatever the software I'm using, and if I want to replicate that particular usage of the software to all the users, then I should install that software into the root user. Okay, you can say that as a global user. And whatever the activities you are doing for the global user, which are obviously reflecting to your remaining users. So once you log into your username, then the Hadoop installation begins. Friends. Okay, so Hadoop software, maybe now you can see as Hadoop 1.x initially you can see, and thereafter that document also I will share both Hadoop 1 and Hadoop 2. And more or less Hadoop 2 and 3 same kind of thing, except that versions 2, 3 are same friends. Okay, but Hadoop 1 and 2 there is a biggest difference. And today I will try to give the difference between one and as well as the Hadoop 2 version conceptually and architecture wise also. So just to see that after getting this also, because this Hadoop you can download from the Apache. So just you can see here um, Apache Hadoop download. Just to go to this and download Apache Hadoop. Click, and obviously what it does is just it is giving us the latest versions, and you can see the old versions also. Okay, some kind of old versions and all. So then once you download these kind of the conventions, okay, so or else clearly you can mention Hadoop 1.0.3, the stable version, guys. Just you can click on this. Okay, older versions will be getting. Okay, so just you have a look on this and find out the proper version. Or else if it is perfectly all right, friend. If you are installing new version, is pretty good actually. Just as a practice, I'm saying you can go through. And thereafter, one of the important points is um, if you are talking about the Windows, there is a folder called there is a environmental folder called regedit actually registry editor. Registry editor, what it does is just whatever the new software installing, that will be registered with that. And there, if any reflection is there, it should register there. If you are or if you are going to install something or if you are removing something from the control panel, all the registry editings will be done to that folder. Similarly, here we are having the bash RC friends. Okay, so this bash RC, what it does is the main important aspect with the Linux is simple, friends. So in case of the Windows, you need not explicitly convey the information of the installation, especially in the Windows operating system. Once the installation is over, automatically Windows operating system takes care about configurations or activity handling or access of the data, everything. But Linux is not like that. Explicitly, you should mention that where you have stored your data and all these paths you have to mention. Okay. So as I said earlier, you're having gedit or vi, both are editors only. This bash RC, if you are opening, it will give some space fields actually, like notepad or something like that. There you need to specify the path. You know, here export Java underscore home, wherever you have installed your Java, and path. Okay, just I need to mention this Java home because friends, entire Hadoop ecosystem is running on top of the JVM only. So definitely you have to install Java and you need to mention the appropriate path of the Java related to this convention. And thereafter, I am setting the Hadoop home also. If you see the differentiation, this USR is belongs to the root actually. Okay, root user always start with the USR. So according to that, you can observe. But your home folder is nothing but your local file system. So in the local file system, just I am picking up this Hadoop installation, and you can mention the path. Obviously, along with the Java path, this Hadoop path also mentions. Now, after saving this particular bash as thing, so as to reflect these particular changes throughout the Linux environment, you need to give source.bash as, okay, for reflecting environmental variable. Just you can make use of that. And to confirm that, just echo is a command where you can see the associated values related to this Java underscore. So generally, friends, we don't install anything, maybe in our projects also and all. Directly, we'll be getting from the support team already installed version, already images or virtual machines pre-configured from AWS and all. Don't worry about this installation because some members are asking me personally. Okay, just I want to license some kind of information to you so that I'm bringing this particular aspect. Okay, to simplify your activities. Okay, and one more thing, guys. Here, once the installation of Java and Hadoop is over and setting up of user creation, and thereafter the bash RC modification, then there are certain configurations of the Hadoop. Okay, because while talking about this Hadoop kind of thing, most importantly, we're having the core site, which is providing us where our entire data is going to store and reside. Because as I said, the name node is one service where I can make use of that particular name node for my entire metadata information. So explicitly, the administrator should specify where this particular metadata is going to store. So that is the reference of the core site. And if you observe in the XML format, we are writing these things. Okay, because the file itself is the XML. So just what we are mentioning, we are giving this property information. And then one more thing. Suppose if you see this big data cluster, it is something like some IP is there, port number, where with this port number only, I can able to access the information and communicate. Similarly, whatever the number, friends, port number, but if you are giving 1234, you should give 1234 so as to access the data of the name node. If you are giving 6789, that port we have to give. It all your wish. But one point is it should not start with zero. Okay, as a typical networking kind of thing, or while using any kind of while establishing any kind of communication, zero should not be the starting character. You can use 1234, 1024, okay, whichever the means you want. Okay, here I have used this 6789 for the sake of storage. And similarly, we are having the MapReduce site. You clearly observe here, guys. What we are saying here is mapred.job.tracker, because this job tracker is a kind of um, uh, machine, or is a kind of service where it is allowing us to perform some kind of the job scheduling and monitoring of the tasks, all these things. So I am configuring my job tracker into the port 1234. And here HDFS site, you can observe here, guys. This site, what it does is it is allowing us to perform the replication. But as I am installing in my local machine, I am giving this as one. Okay, though if you are giving three also, it won't make any sense, because in your machine, if you are storing thrice or five times also, if any problem is there to that particular machine, we may not recover the data. So the idea behind the replication is, suppose if any XYZ machine is facing some issue, I can get the information from ABC. So that is the understanding. Now, finally, the reflection of this Java home, there is some other kind of thing which is known as Hadoop environment.sh shell script print actually. If you are seeing this Linux kind of environment, there are certain scripts called shell scripts, like how we are writing our Python scripts, we are having the shell scripts. So there in this eighth line, just you can mention the Java underscore home wherever you have installed these things. That's all, guys. Okay, see, these are all the steps. Maybe typical steps. I'm not saying this is dead easy. Of course, easy, but not difficult. Okay, but only the thing is, you have to spend your time, and maybe two or three members together. You can take this as a kind of assignment, and you can uh, install in your machine. Okay, take care. Just to install, definitely first you have to install the virtual machine. On top of that virtual machine only, you are going to install this Hadoop. You may ask me this question: how do I install Linux and virtual machine? Maybe some images would be there, guys. CentOS. Ubuntu is also perfectly all right. On top of virtual machine, first we have to install Ubuntu. After installation of the Ubuntu, then you can start installation of the Java, Hadoop, and maintenance of the user creation, bash RC, all these configuration, core site, HDFS site, MapReduce site, and giving the appropriate path of Hadoop. All these things follows. Okay. Now the final step. Okay, everything is fine, guys, up to now. So just we are ready with our Hadoop and all our Java kind of installation. Now we need to start the services. So before starting of the services, because the name node, guys, which is a central part, and which is the minimum aspect for the Hadoop distributed file system. What you can observe is here Hadoop name node hyphen format. Yes, this is the command. Then obviously every setup, just Hadoop will verify, okay, all these properly configured or not, all these kind of things it checks whether Java is there or not. And then you can start with start all.sh. Okay. So now if you see the JPS, which is a currently running, whatever the process is currently running on top of the JVM, you can see name node, secondary name node, job tracker, task tracker, and data node. Now, as you are managing manually, so don't abruptly stop the server. You can stop all.sh. Okay, here all means all the services, no matter whether I'm using the HDFS services, whether I'm using the MapReduce services. I want to start all the services. Five services are there, however, name node, secondary name node, job tracker, task tracker, and data node. And to stop the Hadoop services, just you can go through the stop all. So this is the way how you can manually create the thing. But in our case, we are not using any start or something in friend. Directly, we are moving ahead to the Hadoop environment, and we can able to add because that is a pre-configured one. If you are talking about the pre-configured one, obviously those configurations you need not do. Okay, just directly you can start with your commands and usage of the import, export, copy, move, or whichever the means you want. Okay, so this is how you can go ahead and make use of this thing. Along with this document, I'll be sharing other document friends, which is the installation of the Hadoop 2 or 3. Uh, but my strong recommendation is try to install this one because this is pretty handy. Initially, whatever the MapReduce one and whatever the aspects of command orientation, all these things you can do. Suppose if you want to perform some MapReduce 2 or AIR, and one more important thing, friends, once you install Hadoop, it is very easy to install Hive, Piglet, Scoop on top of that Hadoop. Okay, just we are ready with Hadoop. And what you can do is simply you can integrate your only integration in the sense just to unzip that scoop or hive and only go to the bash RC. Okay, whatever the bash RC we are doing now, just to bash RC, export hive underscore home. That's all path. That is only the requirement, only 2 or 3 step process. But Hadoop installation is a bit tricky and because you need to install Java and then create some users, all these things we have to perform. Okay. So with this, just will be starting with our MapReduce discussion. And friends, I need your utmost attention because this MapReduce is really very much helpful. Okay, very much helpful. And this particular, whatever the way we are dealing with the things, it goes on until the Spark understanding. Okay, right. Now, what is this MapReduce? Just let us start with the introduction, and then we'll follow with respect to MapReduce. As per our knowledge, uh, is a simple programming model. Okay, which follows parallelism, which follows the parallelism. And one more important point: MapReduce process only knows Hadoop distributed file system. There is no business with the local file system guys. Okay, if I am launching my MapReduce process, definitely MapReduce make use of this HDFS only. Okay, now uh, let me introduce what exactly MapReduce 1. Okay, I'm not touching on MapReduce 2 friends. You also have a look on this MapReduce 1. Once we are clear with this MapReduce 1, then we'll talk about which are all the modifications, which are all the problems in MapReduce 1, and how the developers of the designers of the Hadoop extended the functionality of MapReduce 1 to the level of MapReduce 2. Those things will follow. Okay. So coming to the MapReduce one, we know that the services related to MapReduce one are job tracker and as well as the task tracker. Okay, job tracker and task tracker. Now, let us try to understand how this job tracker and task tracker are going to communicate while establishing or while communicating. Okay, while making use of some kind of job submission. Let me pick some diagram to understand this particular topic, guys. So, the job tracker functionality, what it does is just it is making use of some kind of the convention, and that particular convention helps us, how to submit the job and how to verify the outcome and all. But before that, internally, actually, if you are talking about the Hadoop internals, internally, how this particular job tracker is making use of the functionality. Okay, so have a look on this one. We'll try to understand the activities of this particular job tracker, and of course, it is a 11 or 12 step process. Okay, so just we are trying to complete six steps. Okay, until the submission of the job. Okay, because these particular six steps are known to us because we're having some certain commands in our mind. We pretty know that the Hadoop distributed file system, how we can import and export the data from local file system to HDFS, all the things we are knowing. Okay, what we are trying to understand here is observe this here, the job tracker functionality we are talking about. So, as I said, job tracker or MapReduce is only aware of the distributed file system. Now, what do you mean by copy of input files is, suppose assume that guys, I want to implement this information. Suppose I'm having the purchases data. I'm having the purchases data. This is the input actually. This is the input file. Now, my implementation is like this. Okay, each product and the corresponding sales. Suppose books are there. Okay, I want to get in a day $5,000 sales happened, and after book this time having the stationery around $10,000 sales happened, and thereafter some kind of uh, home appliances and $15,000. Okay, this is the requirement. Guys. This is the requirement. So I want to make use of this input and I should design some code so as to achieve this particular convention. That is the thing. Now we'll try to understand. Copy the input files. That means this purchases data must be available in the Hadoop distributed file system. Okay, we know the procedure now. WinSCP, with the help of the WinSCP, directly you can take that as LFS and you can perform, or else your Hue login portal is there now. With the Hue login portal, what you can do is whatever the input file I'm having, directly you can upload that particular input file to HDFS. And this is pretty simple. Na? Directly, whatever the input I'm having, I need to copy into my distributed file system. Okay, now submit the job. Very simple way they have said, but this job submit involves many information, friends. Let me give the job submission command of Hadoop. Command of Hadoop. Now we'll see the Python way of submitting the job. Assume that we have designed the application in Python and we are submitting this particular job. Okay. Now the job submission involves like these things. Okay. So basically, the job submission involves see Hadoop. A little lengthy command, friends, but don't worry, I'll explain each and every part. Jar Hadoop streaming latest streaming version is this thing. Though I am writing next line, it is a continuation friends actually. Okay, I need to specify the files, hyphen files. I am introducing this aspect friends. I am having mapper 1.py, comma, reducer 1.py. I'll give you what exactly mapper and reducer, but stay with me guys. And thereafter, explicitly I am mentioning what is my mapper is mapper 1.py and what is my reducer is reducer 1.py. Once I mention all the mapper and reducer, I have to give the input. What is my input, friends? Purchases data is my input, and you should specify the output also. Output. Maybe I'm giving mm, output sales. This is the directory. This you need to submit as a command. Now have a look on this. One by one, I will explain, friends. Uh, Basically, the default language of MapReduce is Java only. Okay, the default language of MapReduce is Java. But now what I'm using? Python I'm using. That means my source files are available in Python. Mapper.py, reducer.py, mapper.py, reducer.py. So So to other than the Java, if I want to submit my job in case of Python or any kind of thing, I should make use of. Okay, I should make use of the explicit jar. Okay, that is what you call Hadoop streaming dot jar. Then observe here, friends. If you give this particular predefined jar information, your cluster observes that this guy is using Python or whichever. Okay. Other than Java, if you want to submit your job to Hadoop cluster, you should mention as a first step as Hadoop streaming.org. Okay, that is understand. Now, what is the second step, friends? Here I am mentioning. Okay, this is the first step, of course. What is the second step? Second step is I am mentioning my files as mapper 1.py Python file, a reducer 1.py. Okay. Now let me give you what is this mapper and what is this reducer. Okay. What is mapper and reducer? Observe here, guys. In this second step, again, we're having the substeps. Every MapReduce application follows the below steps. Okay, follows the below steps. Let me give you the thing. The very first step is whatever the input file I am giving, okay, that input file is going to split into records. Okay, so heavy file we are giving like purchases I am giving purchases data. This purchases data, how Hadoop splits is just it is going to split into lines. That's all. It is nothing but your split phase. Okay, the first phase in the map reduce is the split phase. This is also known as input split phase. Whatever the input we are giving, just it is going to split the appropriate input into the records line by line. Okay, so that is what you call the input split phase. Second thing, guys, after splitting, the data is mapped. Okay, like data is mapped in the sense what it does is mapped into key, comma value pair, key, comma value pair. For example, friends, I am using the purchases data. Within that purchases data, as I mentioned now, earlier, I am having with respect to that purchases data, books are there, books comma one, and I'm having some stationery comma one. Again, in other records, books are repeated, again one, and I'm having some home appliances, again one. Like that, this after splitting your data, it is going to convert the data into the key value pair. Okay, don't worry, friends. First time you will be getting some kind of thing because it's definitely a huge topic. That's what I'm going slowly. Okay, at any moment of time you are not getting that, don't worry. I'll definitely help you and I'll repeat you. But just you sit idle, relax, and be with me. That's all. Just to follow me. Okay. Now, after getting these records, each and every record is split into some words actually, individual words. And after each word, just it is placing one. Though it is repeated, it never minds. It is keep on splitting the data and identifying that particular data into the words, and it is keeping that one like that. Now, the third thing is actually this phase is known as map phase. Okay, this phase is known as map phase. First phase is split phase. Na? First is the split phase. Second is the map phase. Third thing is, guys, after the map phase, okay, after the map phase, the data is sort and shuffle. Because to maintain the sorting process, sorting in the sense all alphabets A1, A2, and so on, X1, Y1, like that it is going to sort out the data. This phase is known as shuffle phase, guys. This phase is known as the shuffle phase. So shuffle phase, what it does is after getting the input from the map phase, it is going to arrange the data in a sorted order. That is what you call the shuffle phase. It's simple, na? Shuffle phase. Last phase, fourth phase is after sorting the data, okay, the aggregation of the data is done, which is the reduce phase. Which is the reduce phase. Which is the reduce phase. Now, this particular reduce phase, according to the above shuffle, see, A is repeated thrice, example, A3. B is repeated 5 times, B5. C is repeated 10 times, C10. D is only repeated 2 times. Like that, Z is repeated 5 times. So that means what it does is it is grouping all the data items and it is going to apply the logic of, okay, apply the logic, how many times it got repeated, these things. And this is nothing but your word count example. Okay, what do you mean by this word count is, just let me give you a conclusion on this. Suppose I have written some paper along with Sahu and Vedant. We have written some research article and we got some good, fair, bad, good, fair, good, bad, like that. Some tweets assume that this is the input data. This is the input data. Now, what is the first phase of the MapReduce, friends? Input split. Okay, again, I'm explaining with the example. Input split. What this input split is? Just I'm having my entire data: good, fair, bad, good, fair, good, and this is the input, and it is going to split into some records: good, fair, bad, good, fair, good, bad. This is the first phase. This is the first phase. What is the second phase, guys? After each word, this is nothing but the map phase. Map phase. After each word, what I'm doing here is good, fair, one, bad, one. Again, next word, good, one, fair, one. Again, good, one. Last one is bad, na? Bad, one. This is the map phase. What is the shuffle phase, friends? See, na? Shuffle phase. Shuffle phase is nothing but rearrangement, sorting. Yeah. So first it is taking bad, one, and next also bad, one. After this B, just we're having F, fair. How many pairs are there? One. Two pairs are there. Fair, one. Next. Uh, Next is the good. In the first record, how many goods are there, guys? Good, only one good is there for the first record, good comma one. And in the second row also, we are having two goods, good comma one. Again, good comma one. That's all. See, the shuffle phase, just it is the rearrangement of the data. And finally, we are having the reduce phase. Finally, we are having the reduce phase. What it does is just it is taking, writing bad, and it is going to count 1 plus 1. And it is taking the fair, uh, 1 plus 1. Now good, 1 plus 1 plus 1. What is the result, friends, here? Two bad comments we got. Fair enough, we got 2. And good, 3. So our research paper, of course, bad, of course, 2 is there, but nearly 5 good remarks we got. This is the activity, how you can perform in case of the input split, map phase, shuffle phase, reduce phase. Now the point, friends, as Hadoop is a framework, in MapReduce process, okay, the first thing is input split phase, where the activity of taking the input data, splitting the data into the records. Second thing is in your map phase, each record is split into the words. In the shuffle phase, after getting the map phase input, it is going to reorder, arrange the data. And finally, I'm having the reduce phase. Now tell me, friends, out of these particular 4, okay, be cautious, out of these particular 4 activities, which are all the activities or need to be defined by the user defined, which are all the activities taken care by the framework. Just to think through, uh, if you see the process, just to think through, and just to before while you are thinking, just let me get one more example for you to clearly observe, okay, into this OneNote, so that you can easily grasp the things. Okay, just have a look on this. Same example. Just I have given some paper published on the Twitter, and I got good, bad, fair kind of thing. Now, in a pictorial representation, I'm having this input data with me, and I'm getting this split. Okay, each and every record by split. Mapping, what it does, just it is picking a word, placing one, picking a word, placing one, like that for all the records. Now, what the shuffle phase is, shuffle just it is rearranging the data in an alphabetical manner. And what is your reduce phase? Okay, 1 plus 1, 2. Car 3 times repeated, deer 2 times repeated, river 2 times repeated. That is the output. So finally, after getting your reduce phase, the output is going to place in the folder or as output thing. Now, just to estimate, guys, just to estimate, according to you, which out of these four phases, actually, if you observe, this split phase is the first phase, map is the second phase, shuffle is the third phase, reduce is the fourth phase. Now, just to give your consent in the comment box, friends, whether one is user defined or framework defined. 1, 2, 3, and 4 also.
Framework defined.
First one is the framework defined. Okay.
Yes. Yes, sir.
What is the reason, friend? What is the reason?
We just input the data and it
And you
Excel
need
does
not
the splitting.
exactly. Automatically, Hadoop does this, friends. Hadoop does this. You need not worry about checking the data and splitting the data because it's a common activity. No? Whatever the input data you are giving, it is a common activity. Very good, very good. Now, what about second one? Second one, developer activity. See, friends, here you need to define the logic. Here, of course, it is the word count application, but maybe sometimes it is. Now we are going to talk about purchase orders and as well as each and every product how it is. So it is you to decide in what way the split should happen. So the second activity is the developer activity, friends. Mapping is the developer activity, and this is what you call mapper.py. Mapper.py. Now think through what is the third phase, friends, actually? Shuffle phase. Shuffle is the default
It's
phase
by
or do
framework.
we need to? It's also framework. Very good. It is also framework. Excellent. This is nothing but after applying your logic. So shuffle. Okay, nothing to, you need not. Automatically Hadoop does this as a framework. Hadoop does this. Finally, reducer, friends. Reducer, it is a developer activity because he has to mention in what way I need to get the outcome. This is this is nothing but reducer.py. Now, just to, we'll consolidate, friends. We'll consolidate. While working with any kind of the functionality, maybe I'm giving some input data, I'm making use of that input data to turn into the output. But in between, we are having four different phases of the MapReduce. First is the split phase. Initially, whatever the input data I'm having, that particular input data is taken by the Hadoop framework, and it is going to split into the records. That's what we are taking the split phase as the framework activity. Whereas the mapping says, maybe in this example, I'm taking the word count because Hadoop is not having any idea about how to split and how to place that one and all. Because in any programming language, the sorting and all these splitting are major activities. Splitting and as well as shuffling and all, they are commonly implemented in Java also and in even in Hadoop framework, especially if you observe this. Splitting and shuffling are the framework activities. Whereas the logic, okay, map phase, reduce phase, these two are the logic dependent activities. So the programmer, the developer should provide mapper.py and as well as the reducer.py so as to achieve his functionality. So as to achieve his functionality. Now, just with this, actually, if you remember, friends, we started with understanding of the job tracker. Okay, we started with understanding of the job tracker. Now, as a part of the job submission, as a part of the job submission, we were traveled until the understanding of this thing actually. So now, if you want to submit the job, I'm having my Hadoop streaming. This is the default package. Of course, we need to copy into the local file system. Now, mapper and reducer are the files which are supplied by the user. And my mapper name is mapper.py. My reducer name is reducer1.py. Input data, however it is available. Input data, however it is available. My output is just I need to give some output underscore sale. And I'll show you after submission of the job how it is created and all these kind of things. Okay. Now, once this is over, so after submission of the job, what it is doing, friends, get the input file information. This client, na, this client is nothing but through client only we are submitting the jobs. Through client only we are submitting the jobs. And while submitting the job, which are all the things you need, friends? First is the input I am requiring. Next is the mapper file I want. A reducer file I want. See, this client need to get all the information. And once this information is over, it is going to split the data. It is nothing but input split. Just now we have seen, no? This is the first phase actually, input split. Now, after in splitting the input, again, whatever the data I'm having, the entire information is loaded with the HDFS. Can someone give me the reason why this input split should be placed in the Hadoop distributed file system? Just observe, friends, one point I clearly made before starting of the MapReduce, and even I can give the hint also here. I can give the hint also here. Okay. Hope you got the idea. Now, why I need to, why this job tracker need to place the split information into the Hadoop distributed file system? Is there any specific reason? Is there any specific reason? Because
It was
yeah,
only the HDFS
excellent,
file. That's why.
excellent, perfect, perfect. See, friends, here the point is MapReduce is only knowing the Hadoop distributed file system. But in the local file system only, you are submitting the job, guys. You are not shifting any Hadoop or something like that. Within this, just I am mentioning Hadoop jar file name, and thereafter I am giving my files information and mapper, reducer, all these like that I am doing. But one more important thing, guys, here, this split phase. After split phase, I need to apply the map phase and then shuffle phase and finally the reduce phase. And one of the important thing is our map reduce process is only aware of the Hadoop distributed file system. That is the reason whatever the development we are having as a part of the job submission, all those things should be available to the distributed files. Okay. So, very good, friends. Thanks for that. And of course, first time while I'm learning 2011, it seems that time. So I felt very, okay, what is this man? This MapReduce is causing some lot of because we is not a complex process because complex process. Of course, we should be very mindful, guys. We should be very mindful. If anywhere we miss out that particular connect, then it creates some chaos. That's all. Okay. So with this, just the job submission is over. That means we have copied the file into the distributed file system, and thereafter we are submitting the jobs with the help of input file, mapper, and reducer. And the client is getting the input file information from the distributed file system, and automatically it is going to create the splits, input splits of entire input. And we know that our MapReduce process is only knowing about the Hadoop distributed file system. So obviously these things should be available in the Hadoop distributed file system. And then job information like any jar files are there, all these things like, here, command, dot jar, mapper, reducer, all those things we are uploading. Okay. Now we have submitted our job. We have submitted our job. So up to this, only we are aware of input, mapper one, reducer one. Now we need to see the internals of that thing, guys. So up to sixth step we have done. Now the other step actually. Within the second step, these are all the sub steps. Don't get confused. Within that particular thing, the sub steps are there. And thereafter, now I am making use of another convention. Okay. So just be with me, guys. Just if you see this is the continuation step. Okay, this is the continuation. Now have a look on this. So from sixth step onwards, we are starting. We have submitted our job. Now job tracker is taking place because job tracker functionality, if I'm talking, uh, job scheduling, split the job into tasks, and thereafter task status monitoring. All these are the activities of the job tracker. Now have a look on this, guys. Just we are submitting the job, and now the activity of job tracker coming into the picture. Okay. Now what it is doing here is as a sixth step, just we have submitted the initialization of the job. Friends, here initialization in the sense giving the job ID. Okay, just verifying the whether input is there or not, whether my mapper and reducer source are available or not. All these things should be verified in the initialization of the job. Okay, if anything is missing, maybe input, even output also it should verify friend, whether the same directory is there or all the activities. Once this particular process is okay, then it is going to read the job files. Can someone give me the what do you mean by this reading of the job files, friends? Just to think through, what do you mean by reading of the job files? Because initialization of the job involves assigning the job ID, input verification, mapper, reducer, and output directory, whether it is there or not. What do you mean by after initialization of the job? Again, job tracker is reading the job files. Which are all the job files, friends, here? Which are all the job
Status
files?
of the job.
What is that? Yeah, can you come again?
Status of the job. Like how is it working?
Actually, split it is. This is the splitting of the job, and moreover, the job files are actually I had mentioned in the command also. We did mention that hyphen files. If you see, go back to the command print actually. Just to observe here, these files I am talking about job files. These are all the job files actually. These job files are nothing but your mapper and as well as the reducer. So those particular files are placed into the distributed file system. Now you observe here, those particular files are placed into the DFS. Now what is the ninth step, guys? Creation of maps and reducers. Don't get confused. Mapper is different, map is different. A reducer is different. Now you see reduces. Okay. To say that, so mapper.py is a code actually. Map is a space or memory. Similarly, a reducer.py is a code. It maps the reduces. This is the outcome, friends, actually. This is the outcome. This is also outcome. So based on your input data, okay, now already we have seen, if you observe, this is the mapper actually. Okay, this particular thing maps based on your mapper code. Based on your mapper code, Hadoop is giving some space, and this is maps. Based on your reducer code, this reduces, and this is the outcome. Okay, now within this diagram, you can easily observe that maps and as well as reducer. Now tell me, friends, what is this job queue? Job queue is nothing but see here. Suppose the job tracker is there. Based on the job submission, maybe it needs three tasks. Assume that three tasks. So it should maintain a queue because the resource must be shared na? T1, T2, T3. Now, one more point here, guys. Actually, this T1, T2, T3, all the data items are available in some data node because it has to get some input. Na? That input is available in our storage relevant aspect, data node 3. Now observe here, guys. Due to some problem, this task tracker 2, okay, task 2 is unable to uh, reply the status to the job tracker. Unable to reply the status to the job tracker. Now, what it needs to, job tracker should establish a new task and it has to assign all the activities of task 2 to task 4. Up to this, it is okay. Up to this, it is okay. But the problem is, after some time, T2 also started responding to the job tracker. Observe here the scenario, guys. Task tracker 1, task tracker 2, task tracker 3. These three are dependent on various storage and they are running their task. But due to some issue, task tracker could not update the status information within the stipulated time. Then job tracker cannot wait for the task tracker or cannot wait for the task. And the responsibility of the job tracker is if any problem is there for this particular task, definitely it has to establish a new task. And it established. But what happened is after some time, task tracker also started responding back to the job tracker. One thing is important, job tracker cannot afford both the tasks because both the tasks are doing the same thing. Both the tasks are doing the same thing. Keeping both the tasks to do the same thing is a burden actually. Unnecessarily, we are wasting the resources. Now, what is the solution, friends? What is the solution for this? Because while running the heavy jobs, definitely this kind of the situation arises. Some of the tasks may not respond, or some of the task trackers may not conclude the appropriate activity, maybe due to access delay, or maybe it has to wait for some other task to complete, whatever the reason. But however, at least that information should be conveyed to the job tracker. But somehow task tracker unable to communicate the same with the job tracker. Then the ultimate goal of this particular job tracker is to utilize the resources in the efficient manner. So in that way, job tracker assigns another new task so as to complete this particular task to the portion of the task. Now the surprise is this task to old task also started responding back to the job tracker along with the task force. Now, can you give some strategy how this particular job tracker need to go? Because one hint I am giving, definitely job tracker is not happy with both the keeping both T2 and T4. It has to take the decision of either I should continue with the T2 or T4. Now, what is your analogy on that, guys? Just to think according to the MapReduce aspects, and you give me the uh, response, guys. Because in case of the failure of the data node, there is no problem. Directly name node can take the another data node and it has to place that. But job tracker functionality is tricky, guys. It is a process actually. It's not a storage. That to parallel process. And moreover, once that task is running, and if that particular task tracker is not updating the information with the job tracker, then something has to do by the job tracker. Of course, it took the decision of establishing a new task tracker. But the problem here is again the old task also responding back. Then tell me, guys, what is the best strategy to keep only
It
one task
clears
tracker?
the container. It clears the
Uh,
T2 completely.
why T2 clears? It go ahead with the T2 or
No, it removes the T2 clearly from the
removes in the
queue.
sense it kills Sahu,
Uh,
it kills the T2, no, as per your
yes,
thing.
yes,
Any
yes,
other
yes.
obligations, friend? Any other obligations? It is going ahead. According to our friend, he says that it is killing T2 task. But can you justify Sahu why it is killing? Suppose,
It has
yeah,
failed and
yeah, see,
before it
T2
has failed and it
completed,
has
uh, T2
yes.
completed 80% of the task, T4 completed 55 percentage of the task. Now you tell me, still this job tracker should kill T2 or T4?
A T4 in this sense.
That is the point. That is the point. Okay, na? So because see, you are right. As you said, there is a pitfall in T2, and of course T4 latest. Okay, latest task established by our job tracker. But the analogy here is, friends, it is very crucial. Job tracker is merciless. Okay, so what it does is no problem whether I am going with T4 or T2, never mind. But I need to check the status. I need to check the status. Now it estimates the status. It estimated the status. Clearly, in this example, friends, I am talking, T2 got greater status with compared with T4. Then T4 will be killed by the um, job tracker, and T2, it continues with the T2. So this is what you call one excellent topic, guys, speculative execution. Speculative execution. Sometimes, guys, even in our teams also, team member one, two, three, four are there. This T3 member is a little slow in the picking up and implementation. Now, what we'll do? We'll arrange some buddy T1, and you can follow up his activities. Maybe if you newly join in your company, maybe whatever the experience you're adding, up to 2 months or some days, based on the policy of the company, just will be arranging these buddy kind of thing. So what he can do is, along with his work, okay, he can activate, he can push up this guy, and still this guy is not picking up, will change either the department or will change the project or something like that. Here also, guys, the speculative execution, what it does is, just it gives the chance to the task, and if the task is not performing, simply it is redirecting the activities to the other task. It doesn't mean that it is completely eradicating the old task. Benefit of doubt you can observe. And once that particular process is over, now what you can observe is, again, if old member is coming back, old task is coming back and updating the status, job tracker is more than happy, no problem. So but only the thing is, it has to do a little strategy, it has to play a little strategy. How do I get benefited? How do I get benefited? So in that particular case, just it is one simple agenda is, I need to verify the kind of status, and whichever the status is great or good, greater. So just it is going with that particular task. Okay. So this is what how you can specify, and still story is not over, guys. Just to see here the job queue, and based on that particular job queue, it is going to perform the activity. Now the final steps. Okay, bear with me, guys. Today I'll take little extra time before leaving to you break, because in between we cannot leave now. Once this thing is completed, then we'll have a break. Okay, don't worry. So just if you are making use of the convention. Okay, so just I am handling this thing, friends, is the final step actually in the task. So 1 minute, it is not allowing me to copy. Then I have to uh, take the help of snipper. 1 minute. Just a second. Sorry for the delay. New. Just I'm getting this thing. Okay. Now I can take the image. Yeah. So observe, guys, here. As a next step, up to 9 step we have seen. 9 step process, job queue management and all these things, creation of the maps and review. Now the actual execution. It is pretty simple finally. Once the activities are over, so job tracker, okay, now the heartbeat, getting the heartbeat in the sense status information. Getting the status. So job tracker, getting all the task tracker status information. Okay. And then assignment of the tasks. Maybe after completion of one task, it is going to assign some more new task like that. And of course, friends, if any task is not updating the status information, it is going to update the new task. It is going to establish the new task tracker. Likewise, the process continues until all the tasks are going to respond back to the task tracker. And now, once the activity is over, friends, it is going to specify the partitions. Partitions in the sense, let me give you this example. Job tracker established task tracker 1, task tracker 2, task tracker 3. After each task, after performing map and as well as the reduce functionality, it is going to give some kind of the output. It is partition 0. And after performing mapper and reducer, it is going to give the output partition 2. Okay, this is 0, 1. And after performing map and reduce, it is also going to perform partition 2. So that's what the reason. If you are giving the output as purchase underscore output, you will be getting more than one friend at least. Partition 0, partition 1, partition 2. Reason is these tasks are split into, okay, these jobs are split into multiple tasks. And as a result of each task, we are going to get the corresponding partition. Okay. So with this, we can stop here, guys. Okay. So heavy subject, definitely I do agree. But that's how we need to go with MapReduce aspects. But once what we do after coming back from have a nice pure coffee, guys. Definitely we need that. So once this particular thing is over, now after coming back, just I will be showing you how to submit a MapReduce job to your Hadoop cluster. Okay, then I will show you how to submit the job to the MapReduce cluster, which will clears our job submission and practically how we are verifying these kind of activities with the help of our cluster. Okay, so to give a clarity about key takeaways, just we have started with some kind of the commands. Okay, some commands we have seen, and those particular commands are very pretty simple. Okay, so just we have seen some CP, MV, LSR, PI, CAT, like that some commands we have seen. Key takeaways, and then we started with the MR flow. Okay, so with respect to this MR flow, we have seen some 4 phases. Okay, these 4 phases are split phase, which is the framework activity. You need not do anything. Second is the map phase, which is the developer activity. Next is the shuffle phase, which is again framework activity. And finally, we have seen reduce phase, which is developer involvement activity. Now the next aspect we have seen is how this particular job tracker set the tasks and how it is performing the activities. Okay, so these things we have observed, and moreover, an example we have seen. Okay, like how the word count kind of thing. There we observed some set of records we have taken input data, and this data is going to split into some kind of the records. Okay, this is the split phase, and this is of course first phase. And after this particular thing, then we are having the map phase. So this map phase, what it does is just it will give the kind of values. Just it is placing these kind of values, map phase. Once this thing is over, there is a shuffle phase, data arrangement, sorting of the data. And finally, we are having the reduce phase. Okay, so suppose your X value is repeating multiple times, it is going to give the outcome like this, X2, Y3, Z5, like that. And your reduce outcome is the final output. Okay, these points we have seen. And apart from that, we observed some more important topic called speculative execution. Okay, so the speculative execution is something like which gives you, suppose if any task is there, if any task is not responding properly within the stipulated time, then obviously our job tracker is going to establish a new task tracker. And if whole task tracker again responding back, then it is going to verify the status update. Accordingly, it is going to perform the activities. Okay, so there, here I am stopping, guys. Just you can make use of today. Definitely, we have to work more because many concepts are there we have dealt, but somehow we have to start now. So that's what I started this particular discussion. We can take the break. So after the break, again, we'll see the submission of the job, which is quite simple and interesting. Okay. So just Google timer, let me start. And then after the break, we'll meet, guys. Thank you. So, friends, I'm back. Hope you're also there.
Yes.
Please confirm. Yeah,
Yes,
thank
indeed.
you.
Yes, sir.
Yeah. So, welcome back after a heavy discussion. So, like friends, as I said earlier, so now we can make use of our whatever the understanding or whatever the aspects we have seen. Uh, Now let us put in a different way. Like so, after equipped with all our inputs, after observing all our whatever the files we are having, let me show you this ls. Actually, this particular Hadoop streaming is there, friends. If you see this thing, and after that we are having mapper2 and as well as the reducer2.py. And how do I get these things is pretty simple. Just go to the WinSCP. There I am having within the desktop, I have created all my Python MapReduce codes. And there I'm having this purchases.txt.gz. Assume that this is a file where I'm making use as a kind of source file. So this particular source file, let me share the entire screen, guys, so that you can see the WinSCP also. Okay. So if you see this thing, friends, actually I'm having a folder in the desktop. So this is Python MapReduce. I'm having all these kind of the conventions. Likewise, I downloaded this Hadoop streaming 3.2.2.jar because while using the Java, I need not explicitly mention any jar file. Jar file will we generally create. As a developer, you can create a jar file from Eclipse or NetBeans or whichever. But in Python, no such kind of the jar files and all. So as a intermediary kind of thing, just I need to use this particular jar file, executable jar file, that too in the streaming fashion. And I'm having the input data as .gz. So here, let me go to this Q login portal. And if you see this purchases.txt, so I'm having some information with me. It's a huge file, guys. I'm having some huge file. What I'm doing here is just I'm making use of this purchases. Let me delete this. I'll show you how to handle this. So delete this and you delete this from this trash also. Um, Empty, delete. Now we don't have any file as such purchases in the Hadoop distributed file system. Okay. Now what I'm doing here is just you see here and I am making use of this purchases.txt.gz. Okay. So this particular file, okay, this particular file, I am pasting in the local file system. Just it is going to copy the appropriate file, purchases.txt.gz. Okay. Once this file is there, so now if you observe this thing, even purchase.txt is there. I want to remove this file. I can directly remove that. Okay, what I'm doing here. So gz file, which is a WinZip kind of thing. How I am working with the RAR files and all. Similarly, in Linux, I am having the gz file. Now I do have this gz file in my local file system. Then how do I make use of this file into the normal text file? So just go back to this thing, and there is a command called gunzip command and purchases.txt.gz. Okay, so just I am entering this thing, guys. Now you put this ls. Now I can see this purchases.txt. So simple. After getting your purchases.txt.gz, simply you can make use of this gunzip. Gunzip is a command where you need to unzip this particular file. Okay. So now we are ready with our input. We are having our input data. And of course, similarly, if you see this appropriate information, item and cost list corresponding whatever the item I am having and corresponding cost. Okay, just I want to display the item and as well as the cost list. So just I am making as usual, simply copying the details to local file system. So you can easily observe that that mapper to reducer is also there. So just you can give the ls. I'm having my mapper to file and as well as the reducer to file. Now the point is we should copy this purchases.txt to the HDFS. The reason is, friends, reason is our MapReduce code is only knowing about the Hadoop distributed file system. So for that, what I'm doing Hadoop fs hyphen copy from local. So I'm having the purchases.txt. I'm just using the purchases input. Okay, just I'm renaming that purchases input. Just that huge file also simply it copied. Now if you observe Hadoop fs hyphen ls, then automatically I can see this purchases input file. Is a lengthy file. Okay, reasonably. So now we are ready with this thing, and even Hadoop streaming .jar is also available with us. Now let me show you how do I submit the job. Okay, so just I'm clearing the screen. Okay, and I'm just I want to notify the purchases. Uh, Let me show you that ls Hadoop fs hyphen ls. I'm having the purchases underscore input, and in case of the ls, we are having this mapper 2 and as well as the reducer 2. We are having this Hadoop streaming also. Now what do I do? Just I need to submit my job. Have a look on this, guys. Hadoop. I am mentioning the jar file information. So jar file already there na Hadoop streaming.jar. Just I am typing only first three characters and I am giving the tag. Automatically, if, as no file is there related to this Hadoop starting with HAD, obviously only one file is there. So it is automatically taking that name. Okay. And next is I should give the files information. Okay, my files are available in mapper2 and reducer2. So mapper2.py, comma, reducer. So reducer2.py. And after giving the files information, these files are nothing but the job files. I'm conveying to Hadoop. Okay, hey, I'm using other than Java. So just I'm mentioning this jar file as Hadoop streaming 3.2.2.jar. And just we are making use of the job files as hyphen files, mapper2.py, reducer2.py. And next thing is explicitly I have to mention what is my mapper. I'm guiding this mapper2.py and I should give what is my reducer.py. Okay. And as usual, I should explicitly mention the input purchases underscore input. From the HDFS friends, I need to give not is not there. So as it is purchase underscore input. My input file must be in the HDFS, not in the local file system, friends, because MapReduce requiring the appropriate file information. Okay, that input file must be there in the HDFS. Now the final thing is output I have to mention. Okay, output. As I am working with the MapReduce underscore purchases. So this is the output file I want to give. Now have a look on this. So in our example also, we have seen just I am taking the Hadoop jar, whatever the jar file I'm having, Hadoop streaming, just I am mentioning that. And I should mention the files information, mapper2.py and reducer2.py. And explicitly, I should give the mapper information, mapper2.py and reducer information, reducer2.py. And I'm giving my input as purchase underscore input. Just I'm mentioning the output as mr underscore purchases. So this is the first time we are submitting our Hadoop job to the cluster. As of now, just we have entered some commands, and those commands are either import or export or listing of the appropriate files, all those things. Now we are submitting our job. So just I'm entering this thing, friends. Okay, once you enter this particular notion, Okay, it is start launching. Okay, see, just it has given the ID. Okay, first thing is job ID should be given. A map is going to establish map and parallel job. No? This is a parallel. It follows the parallel process. Just map it is taking. It is a huge data, and that too we are running some kind of the mapper and reducer. So it is taking some time. So map 100% completed, and it is after completion of the map again it has taken a pause. Reason is shuffle phase is there. No? It has to shuffle the generated output, and then that shuffle output should be given to your reduce. Now this reduce is taking place after completion of map and shuffle phase. Reduce is taking place, and after completion of the reduce, it is going to write the appropriate generated output into the mentioned output directory, whatever the output directory you have mentioned. See, periodically it is showing a 0, 27%, 53, 67, 71, like that. It is picking up all the data. It is picking up all the data, and it is going to uh, 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 maintain that particular output as partitions. At a time, we are not getting the outcome. Now, you see, after this successfully, after completion of this thing, if you observe, my whatever the job I have taken, actually 5 months, initially it has given the ID of the job, and it is making use of map and reduce kind of the pages, and it is confirming us, yes, your job is completed successfully. Now friends, uh, maybe some optimization techniques you may apply later point of time, because while submitting heavy jobs or while using the clusters, it is always important to verify how much amount of the memory we are consuming, and in what way we are spending some time, and all these kind of the conventions. So actually, these things you can easily observe, friends. Number of bytes read, how many bytes written, okay, all these kind of the conventions, and how many map tasks are launched, how many reduce tasks, okay, and occupancy, okay, in milliseconds. All these kind of the convention, everything is there, and in MapReduce framework, because these are all the activities related to mapper and reducer, and of course, your MapReduce framework is also doing some activities like garbage collected time and CPU time spent, and as well as the physical memory snapshot, see whatnot, all the things, and then the shuffle kind of thing, how many input bytes read and how many bytes we have outputted, all these kind of conventions. And finally, what it is saying is that your job, the output directory is MR purchases. Now, let me show you what exactly that MR underscore purchases consist of. Clear? Okay, so just we'll have a look on that, guys. So just we have to pick up those kind of the conventions. Let me display Hadoop fs-ls so that I can see the name of the directory. This name, friends, mr underscore purchases. So Hadoop fs-ls mr underscore purchases. So just you can see this particular folder, what exactly this containing. As I was talking about partitions of the data. You see, guys, here partition 0, partition 1, 2, 3, 4, like that. The first file is giving the success. That means this particular output folder, it is containing the actual outcome along with the status, whether this job is successfully completed or any warnings are there or any such kind of aspects you can see. If you see this success, then you can make use of, okay, I have submitted my job and it got completed successfully. This thing you can observe, and along with that, various partitions of the data we are having. Now, so as to pick up this data, two methods are there. No? One is I can make use of the cat Hadoop FS hyphen cat, and then we are making use of MR underscore purchases, MR underscore purchases slash part hyphen. Just there is a convention, friends, here. Okay, just it started with five zeros, and accordingly it is going to give the output. Now just you can enter that so as to pick up the output. This itself is a bigger output. Okay, actually what we have implemented is this particular job giving us the purchases data, items and as well as the cost list, items and as well as the cost list. So rather than verifying one by one, just you can go ahead and here as of now there is no MR underscore purchases data. Just to refresh it. Okay, just to refresh it, and now I got this MR underscore purchases. Just to click on the success, of course, which is not having anything. Just it is giving the information about the file, okay, permissions and all. That's it. And now, if you click on this, which is giving us health and beauty, how much cost we have spent on it over the period of time. And next thing is second partition, books, and third one, it is something like children's clothing. Next partition, okay, because these are all the subtasks actually on baby products. Last one, some other crafts. Okay, so all these tasks segregated the appropriate input, and they could able to separate the appropriate outcome, and you can see as a partition kind of the data. So that is what MapReduce is a typical programming model where it is giving some kind of the convention, like it is taking the input data and launching that mapper and reducer, all these kind of the conventions. Okay, and now at times, friends, maybe some other logic. Okay, some other logic maybe logic. There is no end for the logic. Maybe especially the programmer's perspective, programmer can think in any ways, and clients are also having many requirements from us. So in the same way, just so as to habituate the job submission, so just I want to mention some other aspect. Suppose well, still it is loading this. You see? So just rather, that's what I'm saying. Always it is better to go with because such a huge data we are having. So such a huge data, still it is fetching and giving that information. Okay, always this command prompt is trying to fetch that. And meantime, what you can do is just you can go to this thing and you can start one more web shell. It's a distributed environment. No? So um, let me log into this thing, uh, big data mind one and big data lab. Okay. So now I'm having some other information for you guys. Product total. Product total in the sense now in the earlier example, what we are getting is individually all the product information on a day wise or something we are getting. But whereas if I want to mention the total sales happened so far, so for that I'm having some example, product total mapper and product total reducer. Okay, this is one more example where I can venture. So I'm mostly interested in running one more job and submission of one more job, friends. Okay, so be with me, guys. Just I'm running this Hadoop jar. Okay, what is the streaming file, whatever I'm having. Now I need to give the files information. This time product total mapper, comma, product uh, total, uh, product total, what is that, reducer. Okay, .py. These two are the files I want to venture. And then I should mention the mapper data. What is my mapper data? Product underscore total mapper and my reducer data. So I have to mention the reducer data also. Just I'm giving this thing and input. Okay, input must be from the HDFS now. What is my input name, friends? From the HDFS. Uh, just I'm refreshing. Purchase underscore input. Okay, this is my input. So just I can take purchase underscore input. Okay, purchase underscore input and output. I can mention MR underscore total sales. Something like some meaningful information. Later we should not feel where I have kept my output data and all. because these are all batch processing, batch jobs and all. Heavily they are incurring the time and as well as the space requirements. So Hadoops are just I am mentioning the streaming, Hadoop streaming 3.2.2. Files information, product total, mapper, and product total reducer. They're all the job files actually. And explicitly, we need to mention the mapper information, product total mapper, and as well as the reducer, product total reducer. Like that, and I should mention the input from the Hadoop distributed file system, hyphen input, purchase underscore input, and output, just I can mention MR total sales. Okay, just you can give the enter, and you can observe this string print actually. Here it's launched with the ARN actually. ARN I have not discussed so far, but both in MapReduce 1, MapReduce 2, whatever the things, your job submission is same. No matter whether you are working with Hadoop 1, 2, 3. But only the thing is in Hadoop 1, we are working with only MR1. But from Hadoop 2 onwards, we are having the ARN application. Okay, I'll give you, before leaving this session, I'll give you which are all the problems with uh, Hadoop 1. Okay, and how we are going to launch Hadoop 2 or 3. Because at times, guys, Hadoop 1 still some countries are using because they don't want to integrate with Spark or PySpark or Scala kind of thing. Because in case of the MapReduce 1, only that MapReduce 1 is used by Hadoop. Okay, but whereas if I want to establish some kind of PySpark or other kind of the integration, then I should go with the AND. So ARM is a cluster management tool. Okay, I'll talk about that in a while. But just to observe that from Hadoop 2 and in Hadoop 3, we are making use of the ARM, which is a cluster resource manager. You can easily observe that. And now try to understand this code, how it is behaving. So just we have submitted the job. This is the job ID. And after submission of this particular job, it took some time to run this mapper and as well as the reduce activities. Now has updated. Hadoop updated as your job is completed successfully. And as usual, it is giving us the appropriate statistics, okay, used by Hadoop framework so as to submit, so as to store and execute the appropriate job. All these kind of the conventions can be observed. And framework relevant activities and all these usage of physical memory and virtual memory execution, all these things you can observe. Okay. Now our data is stored in the MR total source. Okay, this particular directory is containing the outcome fields. Now, better thing is first you can confirm here how it has how many partitions it has taken Hadoop fs-ls. Okay, then I want to see how it has been located. So then Hadoop fs-ls mr total sales. Like that, I have given my directory information mr underscore total sales. So just if you observe, here also partition 0, 1, 2, 3, 4. Observe friends, if you see any such kind of the files as the input, maybe you are a PySpark developer or Java developer or Scala, whichever, and if you want to mention, if you want to get, or if you observe any such kind of files in this format, that is definitely the MapReduce outcome, friends. Okay, it is how it is doing is just it is running the task individually based on the job tracker functionality, and accordingly it is going to submit the jobs, and task wise it is going to pick up the outcome, and like that only the outcome is writing to the Hadoop distributed file system. Okay, so as usual, first is the success, and 0, 1, 2, 3, 4, like that partitions data we are having, and corresponding number of bytes also you can observe. Now let us see how it is running. So here no such kind of MR total, though it is there, but it has not reflected. Just you can refresh. Now you can observe MR total sales. Click on this. Now success as usual. You can confirm that our job got successfully completed by MapReduce engine or Hadoop framework. And if you see this first partition, your health and beauty, this is the total cost. Video games, This is the total cost and women's clothing, this one. Like that in the first one. Earlier we are having many things and all. Now books, total sales and CDs, consumables, consumer electronics, and garden related appliances, pet supplies. Maybe that is a that purchases shop is containing all the goods like this, sporting goods and all. And coming to the next one. So in this partition, so maybe it is taking some time. So that's what guys. So sometimes again you need to establish the communication with the master because that master, is the name node. So which will be giving the metadata information. So children clothing, men clothing, toys, and then this thing, cameras, computers, and DVDs, and based on the input data, friends, based on the input data. So this is how you can verify the usage of all these kind of the conventions. So maybe one point left here, guys. So if you want to see the code actually, like maybe I don't know how many of you are Python background, how many of you are having Java background. That background is definitely not required, guys. So as to submit the job, so as to help other team members. You need not be a typical Python program. Of course, as a second part, once the ARN and Hive completed, after these tools, we definitely see the Python essentials for this particular big data tools. At least reasonably, you should understand the code and all these kind of the things. However, I will be scoping those kind of aspects also. Okay, let me clear, and I'll show you how the appropriate mapper and reducer looks like. So first, let us see the mapper 2.py. So just to have a look on this, friends. Okay. In case of the Python orientation, there are certain imports, and we are defining a function, user-defined function mapper. So clearly, I have mentioned the comments also. So input line by line per line and strip of extra white spaces. Split is a function where all the tabs or extra spaces can be removed and length of data not equal to 6 continue. Okay, so just I am mentioning that each and every length of that particular data item and here certain code, okay, item and as well as cost. So I want to pick up that item and corresponding cost. That's it. So it is all typical Python environment. And similarly, your reducer. So let me clear this and the reducer py. Don't worry about this understanding, friends. Again, we'll be coming back to this. But the way how the Python programmers supply the code to us, that's what I'm talking about. Okay. So this particular reducer, after getting the input data, just we are making use of this particular key. If already existing key is there, you can add the. Sometimes suppose books. This day some purchases happened. I want to skip that books and today how many baby products are purchased. So likewise some kind of the coding so related to the logic you can make use of that convention. So this is the first example we have seen. So first example, just if you observe the submission, uh, not this one, earlier one. So this particular submission. So that submission, what it does is just we are making use of Hadoop jar, streaming, and files mapper, reducer, and explicitly you have to mention the mapper code and reducer code. Again, input and as well as the output. Now, after this particular thing, let us see how this product sales and all are there. So just I am making use of cat and product total mapper.py. So this is simple code compared with earlier. So just I am making use of some display of the data, format, item, comma, cost. And in the reducer only, I'm going to get the total price. So let us see that logic also. Cat product total reducer.py. This is bit lengthy program. Okay, just whatever the data we got, just we are applying the same kind of the convention. We are finding out of the each item. Okay, whatever the item we got related to that item, what is the total cost of the item? Okay, so likewise, the programmer supplies this particular data to us, the source file, and accordingly we are going to perform the activity. And on top of this, just we need to understand the input data also, friends. What is our input data? Purchases input. What exactly it is containing? It is containing the date information, time they have purchased, and the city of the purchase, what product they have purchased, and how much amount they have incurred, and in what way they have paid our what way they paid the bill. Okay, so Mastercard, cash, MX card, and Mastercard. Like that, we're having some information. So based on this particular input, according to this corresponding logic, our MapReduce could able to fetch the information and it is able to perform the activity. It's a heavy coding. Definitely, all these activities are not that much simple thing because many members should be there and all those members they should share the input data item with us and they should share the source files and then we have to see whether that is a Java based kind of thing. But basically, guys, if you are working with Java, then your Hadoop job submission is bit different. Let me show you that also. In case of your Java orientation, only you need to do is let me open this OneNote and just as a glance thing. Okay, it's not definitely a deviation. It's a simple mechanism. What is the difference between Python submission and as well as the Java submission? If you observe this a Python submission, just now we have seen in the Python way of MapReduce job submission, if I am talking, just there are certain parts. Very first part is Hadoop, jar. Then I need to give the Hadoop streaming 3.2.2.jar. This is the first thing. Second thing is I should mention the files information. I have to mention the mapper2.py, comma a reducer 2.py. This is the second statement. And my third statement is I should mention the mapper explicitly, mapper2.py. And as a next statement, a reducer also we have to mention reducer2.py. And of course, this is common input. In either case, I have to mention both in Java and Python. Input is purchases underscore input. It should be in HDFS. And output, of course, your MapReduce after completion of the MapReduce job, suppose if you are giving MR underscore output one, this is going to available in your HDFS. This is also available in HDFS. Okay, so this is a typical Python orientation, guys. But let me show you in case of Java how we are going to submit Java MR job submission. Suppose I am having the Eclipse with me. Okay, within the Eclipse, I have to write mapper, reducer, because these are all class files. No? That's what I'm not mentioning any extension. And there is one more code called main function. Within the main, I'm mentioning the driver code actually. This driver code is sometimes known as the main code also. So this driver code refers again mapper and as well as the reducer. Okay, I need not explicitly mention the mapper reducer in the Java. Within the driver only, I'm going to devise mapper and reducer. Now, how do I submit the job? See here, friends. Assume that I have exported. I have exported my .jar file as mr1. Okay, this is my jar file. This jar file is containing the driver code, and within the driver code, I have embedded a mapper class, reducer class, mapper class, reducer class. Now you have a look on this page. How I am doing this? This is assume that mr1.jar I have exported. Okay, so Hadoop. Okay, so Hadoop jar. My jar file name is mr1.jar. And then friends, what I need to give is this is the first statement. My second statement is okay. my second statement is I should mention package name dot driver class name. This is my second statement. After mentioning this, simple input purchases underscore input and output hyphen output mr1 underscore java. This is the fourth one, friends. Okay. Now, in a typical Eclipse environment, what you can do is you generally use the package. So package, maybe I'm using MR1 examples. Okay. And within that, I'm giving the driver name as in the main function. I'm mentioning that maybe example I'm taking as word count driver. Assume that word count driver. Now, how do I submit this job? Okay. So simple Hadoop jar. Maybe you would have exported the entire code into mr1.jar. Assume that your entire code can be simply just you can go to the file menu, export and .jar file, mr1.jar. So just I am giving the mr1.jar and thereafter my package name is mr1 examples dot my driver program word count driver. That's all. That's all. And then as usual, input must be there now. On what input I want to apply? Input your purchases underscore input, and you should give the output mr1 underscore Java. Like this, you are going to submit. And now, if I am comparing this Java orientation with Python, okay, there is no package or these kind of things. And moreover, if you observe this, there is no jar file in Python, so I need to use Hadoop streaming. Hadoop streaming. And my MR1 examples word count is there. Now I have to use files here, job files. In case of the Java, I am having the job file information as my uh, package name and as well as the class driver class name. But there is no such class names I kind of thing in Python. So just I need to mention the mapper and as well as the reducer information. And input output remains same, but before that, I should mention explicitly the mapper and I should mention explicitly the reducer. Mention the reducer, and of course, input remains same, output also remains same. Okay, see, the development here is, guys, initially, while Hadoop is working with the MapReduce only, so they are very happy. But once that Hadoop designers released that ARM kind of thing, let me show you why Python is coming into the picture in the Hadoop orientation. Is a little history is there, guys. So Hadoop 1.x, what is the problem? Is mainly two problems. One is single point of failure. This is the first problem. I can say limitations. Okay, this is the stepping stone for ARM actually. And B is uh, job tracker overburden. See, if any person in the company or team overburden means is a dangerous deal. Na? So similarly, in this thing also we are having job tracker overburden. The reason is simple. Can someone name which are all the functionalities of the job tracker, friends? Okay, job schedule, job split, job monitoring, task monitoring, cluster management. See, if you go back and verify, just have a look on this, guys. Uh, if you go back and see the way, so still it is running. Okay, no problem. if you observe the way job is running, let me run once more, no problem. Yes, it is. Hmm. Just if you see this thing, how many activities it is doing. If I am giving the output like this, it is definitely returns the error rate because already your output existing. So again, go back just to add one more one like another directory. Now this time see many activities are taking place. All these activities before advent of the ARM should be done by job tracker only. Assignment, management of the cluster, holding of the MapReduce, packing the entire things, and submission of the appropriate output to the directory, everything. So this particular convention caused many troubles, friends, actually. And the reason is simple again. Job tracker is also single point failure. Your job tracker is also single point failure. If your job tracker fails, if job tracker fails, then everything is going to get affected, friends. Entire cluster, job, task, everything is going to affect. All the jobs are literally going to shut down. Okay. Now what they have done is they came up with a nice analogy. They came up with a nice analogy like to address the first problem, single point of failure related to the name node. Okay, what they have done is from now onwards, we can refer this point, guys. They designed rather than the secondary name node, they designed name node active, name node passive. Okay, that is the reason in our 7 node cluster, okay, 2 nodes are there. Okay, one is the active name node, another is the passive name node. Passive name node. That means whenever there is a problem is there for the active, immediately passive will be activated without any delay or without losing any information. Remaining 5 nodes are there. No? All these 5 nodes, however, they are data nodes. Data node 1, 2, 3, 4, and 5. Of course, this is as usual. These all 5 data nodes remain same. Now, now the ball is coming to job tracker. So how do they handle this thing? SPOF or overburden of job tracker. Now the research friends, actually why I always admire about the research is they have done a lot of research on these guys and they felt that because job tracker is handling all the cluster management and all the job monitoring, all these things, why can't we separate these two things as a individual entries? So what they thought is our entire cluster management giving to app. And of course, this job monitoring now onwards, we're having resource manager. Okay. And so in support of this thing, we're having the node manager. Okay. Observe this, guys. Okay. Now this Hadoop 2.x or 3.x becomes in case of the now I'm having certain services with me. Of course, name node remains same. My data node remains same. But instead of the job tracker, now I am having the resource manager. Instead of the task tracker, I'm having the node manager. Okay, this is fine. Now there is no single point failure. Reason is I'm having the passive name node. Data node, absolutely the same functionality. Actual storage. Your resource manager, nothing to do with the cluster management. No cluster management. Clearly, how they have defined is your resource manager is to monitor the appropriate mapper reducer and to take care about the tasks, status updates only the thing. Memory management, everything is taken by the cluster manager, which is an. What do you mean by this? An is nothing but at another resource negotiation. Okay, at another resource negotiation. This is the and. Now you may ask this question. I understand Hadoop 1.x uh, job tracker is doing everything with the help of the task tracker. In Hadoop 2 and 3, I'm having instead of this job tracker, I'm having the resource manager. Instead of task tracker, I'm having the node manager. That is, I can agree. But why you are talking about MR1 and MR2? Yes, I'm coming to that point, guys. I'm coming to that point. Reason is MR1, Hadoop 1, name node, single point failure preserve, job tracker, cluster management, everything, all the plenty of things are there. Na? Job scheduling, task monitoring, everything. Okay. Now this thing is belonging to the MapReduce 1. It is only supplies Java orientation. MapReduce 2, from Hadoop 2.x onwards, what they have done is your MapReduce 2 name node is equipped with passive name node. This is the active name node. There is no more board button for the job tracker. Just we replace this thing with the resource manager. And I'm having ARN as a cluster management. There is a separate engine to run the task. Now, the advent of ARN, okay, the advent of ARN open the avenues for other language names. It is supporting Python. It is supporting Spark. It is supporting R, everything. Okay, so the ARN is not only the cluster management tool for your Hadoop, but there are certain avenues where I can submit my jobs with the help of the Spark, R, and Python on top of this ARN. Now the play is very, it becomes very interesting. Like if I'm using ARN, no matter whether I'm using MR1, MR2, okay, no problem. In case of MR2, we are supporting Python. Of course, we are not leaving Java, everything. And on top of this, even I can submit my Spark jobs also. So that is the understanding. Okay, so MapReduce one limits everything. It has limited, the orientation of the Java and very particular. Okay, so that's how we are going to see the aspects, and that's all for today's guys. And definitely, it is an excellent packed session. But only the thing is, let me pick some 2 to 3 members. So tomorrow I want to hear from you, especially the guys. Let us pick the members. Uh, Sahu, Sahu is there. And Harish.
Yes,
Yes, sir.
Yeah, Harish. Can you do some favor with Vedant is there in the call?
Vedant
Yes.
is here.
Is there? Okay. You do one
Yes,
favor
sir.
to yeah, Vedant. You three guys just to consolidate all the discussions today. Maybe leave that coding part. Only the thing is starting from the MapReduce flow, how job tracker and task tracker are working, and which are all the phases, 4 phases. Can you prepare some presentation and can you present in the tomorrow session, guys, or you need some more time, Monday or something like that, or tomorrow is fine? Because I at least I want to repeat these things in front of our guys. What is our plan
Yes.
on that?
I
Tomorrow
think,
or the
sir,
Monday?
Monday would be better.
Will be better, no? Okay, no
Yes.
problem. Then I will
Yeah,
do one
because
thing tomorrow.
we
Uh,
ourselves have to go through. Today's session was heavy, frankly speaking. So
yeah, that's
Yes.
what.
some reading will be
Never
required.
definitely required, definitely required. So no problem, dear friend. But the justification definitely we can do by presenting the same in front of our friends on Monday. Hope that that is okay with you, no? I
Yes,
think.
yes, sure.
Absolutely. Okay. I don't have
Monday
any
will be.
objection. Yeah. Okay. So just to see that how we are going to wrap up these kind of things. to take some 30 minutes or 40 minutes of the time, but definitely the repetition is required. Rather than me repeating, okay, just you can come up with some nice analogy so that you can have a dedicated time of presentation, 30 to 40 minutes of the time, and will complete. And of course, however, tomorrow I'll be taking about the limitations and how Hadoop 2.x or 3.x are helping the developers so as to implement the things and all. Okay, so with this, we can sign off, guys. But before signing off, just let us consolidate the key takeaways of today's session in a simplest way. Uh, the very first important thing is we have seen some Hadoop commands, very simple commands. And then we started with MR1, which is discussed now job tracker and task tracker functionality. And thereafter, we have seen some kind of MR pages. There we have seen the framework activities and developer activities. And once this is over, we have gone through the job submission. Okay, job submission. Of course, we have seen the context of the Python. And logically, we observed in what way Java file submissions happens. And Hadoop 1.x limitations. And thereafter, this 2.x or 3.x, how they have came up with resource manager and node manager on top of this app. Okay, so this thing we have seen. And in the next session, okay, that is the tomorrow session. So these things I'm going to talk, friends, like um, first we'll see in-depth coverage of MR1 limitations with some case studies and what exactly MapReduce do, and extensive discussion on ARM architecture, and some more job submissions, and how these job submissions are monitored by ARM. Okay, tomorrow also it's not that much heavy, guys. It's not that much heavy. But ARM now is a revised version of MapReduce 1. Okay, that is what we are saying that as MR2, and don't feel that MR2 ARM are same. MR2 is there, then ARM must be there. That is understanding. MR1, if I'm talking, no ARM, no cluster manager there, because MR1 is running on top of our job tracker, task tracker. There is no question of the resource manager and node manager. Just be cautious, guys. Some people interchangeably use MR1 and ARM, which is a mistake actually. Okay, easily the professional can easily grasp that this guy is not knowing anything. If you are talking about MR2, there is no business of job tracker and task tracker. Of course, MR2 is running on top of the ARM. That too, that ARM is communicating with resource manager and node manager. There is no such job tracker, task tracker. Okay, and moreover, one point is secondary name node is optional, friends, actually in 2.x and 3.x. Okay, so in 1.x, we're having name node, data node, secondary name node, job tracker, and task tracker. From Hadoop 2.x onwards, 3 also same. 2 and 3 are having the same kind of the 4 services as I mentioned earlier. Name node, data node remains same. There is no change. But one change is secondary name node is optional in Hadoop 2 and 3. And instead of the job tracker, I'm having the resource manager. Instead of the task tracker, I'm having the node manager. And there is a separate cluster management tool, which is the get another resource negotiation. Okay. With this, just we have done many things, but just to have a look on this, just I'll be posting these installation documents and all these kind of discussions in the Slack. So tomorrow, however, as I mentioned, just we'll go through the other functionalities. Okay. So that's all, guys. Thank you very much, and a little high, but that's how the learning should be.
Thank you.
Okay. So yeah, thank you
Thank
all.
you, sir.
Thank you.
Thank
Yeah,
you.
thank you.